Hello everyone. Welcome back to the channel. In today's tutorial, we're working through question 21. How to find the team size of each department using SQL Server? We'll break down the table structure, write the SQL query step by step, compare two different methods, and discuss their outputs. Let's get started. First, let's understand the data we're working with. We have two tables. Employees table has columns of employee ID, name, age, and department ID. Employee ID is the unique identifier for each employee. Name and age are the employee's name and age. Department ID is the foreign key referring to the department. Departments table includes columns of department ID and department. Department ID is the primary key for the department. Department is the name of the department like IT, HR, etc. Our task is to find the team size of each department. Sort the result by team size in descending order. For example, if the IT department has 5 employees and HR has 2, we want the output to look like this. Now let's walk through the first query that solves this. In this query, inner join connects the employees and departments tables using department ID, so we can get department names. Count over partition by e.department ID is a window function. It counts how many employees belong to each department. It does this without collapsing the rows. Each row still represents an individual employee. Select distinct ensures that we only return one row per department, avoiding duplicate department entries with same team size. Order by team size DESC sorts the departments from largest team to smallest. When we run this query, we get 7 rows, which means 7 departments with the department ID, name, and team size. Let's compare this query to this following query. Here, instead of a window function, we're using a group by clause. This is the traditional way to count the number of employees in each department. Each row in the results set represents one department. The output will give you 1 row per department. The total number of employees per department, sorted by team size in descending. There's no need to use distinct in this query, because group by already consolidates multiple rows into one per group. So which query is better? If you want a compact list of departments and their team sizes, use the group by version. It's cleaner and easier to understand. If you're working in a more advanced scenario, like needing row-level data alongside group statistics, then the window function version with count over partition by can be more flexible. In this case, since we just want the team size of each department, the group by query is likely the better and simpler choice. And that's it. Now you know how to calculate the team size for each department in SQL Server, using both window functions and group by. Now let's move on to question 22. How to calculate the maximum, minimum, and average selling price for each product based on sales data. We'll cover the table structure, explain the SQL query line by line, and understand how to compute prices correctly, even when product sales vary. Let's dive in. We're working with a table called orders, which includes product number, the unique product code, part number, a part-specific identifier, unit retail, the price per unit sold, shipped quantity, how many units were sold, order date, the date of the transaction. Our goal is to find the maximum, minimum, and average selling price for each product. Round the average price to 2 decimal places. Exclude any products that haven't been sold, that is, where shipped quantity equals 0. The output should look something like this. Let's walk through the SQL query that gets us exactly that. Let's see the query, line by line. Select product number, part number. We want to display results for each unique combination of product and part number. Max, unit retail, and MIN, unit retail. This gives us the highest and lowest price this product has ever been sold at. Round, sum, unit retail multiplied by shipped quantity, divided by slash sum, shipped quantity, 2, AS average price. This part is important. It calculates the weighted average selling price. We multiply unit retail and shipped quantity to get the total sales value. Then divide it by the total quantity sold. Multiply by 1.0 to ensure it uses floating point division. Finally, we use round 2 to keep the average to 2 decimal places. This is better than just using AVG unit retail, because prices can vary by quantity sold and we want to reflect that. Where shipped quantity greater than 0, we filter out records where no products were shipped. They're not considered real sales. Group by product number, part number. We group the data so we get one row per product part combination. Order by product number. Finally, we sort the result by product number for readability. Once we run this query, we get 46,317 rows. That means we have 46,317 product part combinations that had at least one shipped unit. Each row gives us the maximum price the product was sold at, the minimum price, and the average price considering how many units were sold at each price point. This gives a complete price summary for every active product valuable for pricing analysis, discount tracking, and profitability review. Let's wrap up. We used max, MIN, and a weighted average formula to get a realistic view of pricing. We excluded unsold products using a where clause, and we grouped and rounded our results to ensure clarity. This query is a great example of how SQL can turn raw sales data into actionable business insights. Thanks for watching. If you found this video helpful, please like, comment, subscribe, and share this channel. Thank you.